Hey again everyone. Today I'm going to be taking a look at a suite of scripts that's under active development and still fairly new to me. With more eyes and hands on this set of tools, I think there can be some real interesting developments with image generation. This is going to be a bit of a dull video with a bit of rambling, so check the description for timestamps if you want to jump to a specific section. I'll briefly cover the major setup steps for the script, a little on preparing datasets, the parameters for the test script, methods for overcoming what are either bugs or things I'm just too stupid to figure out in the script. To close things out, I'll go over using the model in the WebUI, and then show how the model is developing after a different number of epochs in comparison to the base Stable Diffusion 1.5 model. Since I'm not making a lot of videos right now, I tend to have time to update the video descriptions if something breaks or changes drastically. If you have trouble with anything, shoot me a comment or an email. If YouTube doesn't eat the comment, I tend to see them reasonably quick. With email, I tend to get back to people when my health allows. I may not be able to help, but maybe someone in the comments can. This script can be used to fine-tune both Stable Diffusion 2 and 1.5, and can be used to perform the Dreambooth training method as well. Training resolution is adjustable, the scripts support gradient checkpointing, 8-bit atom, and use accelerate, so they're fairly optimized. However, it does seem to still require a 12GB card. As an aside, I did notice something interesting the other day though, and I can't really explain it because I don't have a deep understanding of how PyTorch is allocating GPU memory. Hopefully someone smarter than me can explain what's going on in the comment or point me in the right direction. So I had the auto WebUI open in Windows and I forgot to shut it down. I was running some fine-tuning tests and didn't spot that the WebUI was open until it finished. GPU-Z claimed that the WebUI was using around 2.5GB of VRAM, so the script figured out how to work within the free 9.5GB? When I was running with a training batch size of 2, that's a bit strange. So for now this appears to require a 12GB card, but that could change. Under normal circumstances it seems to use about 11GB of VRAM on my system. So before jumping in, take a look at the author's GitHub page. They've been posting a good changelog at the bottom which discusses new and altered features. Keep an eye on this because any specific information I give in this video could become rapidly out of date. On the GitHub page, the author provides installation instructions for Windows, as well as some examples for Dreambooth training and fine-tuning. For this video, I'll be using Ubuntu 20.04 running on WSL2 Linux on Windows 10 and in an Anaconda environment, so the command line example and paths will differ a little bit from what's on the author's GitHub page. Refer to the author's instructions if you want to try running this purely under Windows. The installation for the script is pretty straightforward, assuming you don't run into any CUDA errors or PyTorch problems. So let's get into it. First, create a new conda environment with conda create -n and then your environment name. In this case, I've named it Koya. Activate the conda environment with conda, activate, and then your environment name. The name of the active conda environment will appear in brackets to the left of your terminal prompt. Next, install some core dependencies with conda install git pip. You can also put git and pip after the environment name when you're creating your conda environment to combine these steps. Now that git is installed, use it to clone the project repository with git clone and the URL of the repo. To update your project files to the most recent version after you've already cloned the repo, type git pull from within the project directory. The command git reflog lists your git pull history, and git revert and the commit ID will revert to a previous version of the source code. Next, install PyTorch and Torch Vision. Now, I'm going to be referencing specific version numbers, and these may not be appropriate for your system, but they are what worked here. For this project, I had to install Torch compiled for CUDA 11.6, even though my system is running 11.7, and I have some 11.8 libraries installed as well. It's kind of a big mess, but still somehow it seems to work. These are big packages, so I'll time-lapse through it, which I'll be doing quite a lot in this video. Next, change back to the home directory with cd tilde or choose your own adventure, and clone the xformers repository. Change to the directory and issue the command git submodule update --init --recursive to fetch the project's modules. I've already fetched and built this project, so the output on your terminal will differ from what you see here. The xformers project can take up to an hour to build depending on your system. Install the xformers project requirements with pip install -r requirements.txt. and then build xformers with python-m pip install -e period. The command that you see on the screen could cause the project to be installed to the incorrect Python version if you have multiple versions installed in your system. If the project fails to build install correctly, you can try calling the build script directory with python setup.py and then develop. Now that xformers is installed, go to the Koya project directory and install the dependencies with pip install --upgrade -r requirements.txt. Next, configure Accelerate using the following options, or use ones appropriate to your system. I only have one GPU, so I won't be doing distributed training. That should be it for dependencies and configuration. So now we can work on a dataset and training script to set up our parameters for fine-tuning or Dreambooth training a model. This script can be used for both fine-tuning and Dreambooth training, but the methods use different formats for the dataset. For this, I'll be fine-tuning the Stable Diffusion 1.5 model using captioned images. The model is still in the oven and will still need more training after this video is finished, but later on I'll show some examples of what things look like as training progresses. The Auto WebUI has a smart processing extension that can be installed from the Extensions tab, but it also has integrated image processing functions which can be found under the Training tab. Select Preprocess Images to bring up the menu and set your input and output directories. For this training, I'll be sticking with 512 by 512 pixel images, so I'll leave these options unchanged. The Auto Focal Point option will attempt to crop the focal point of the image. This can be helpful in most situations, but there is one scenario you might run into with scraped data. If you have thousands of watermarked images, Auto Photo Crop may display watermarks more than the default center cropped images. The preprocessor has two options for tagging, blip and deep Danboro. Danboro tags are brief, comma-separated phrases, and blip captions are typically full sentences. You can use one or both to caption your images. That said, the auto tagging should be viewed as a potential time saver rather than an all-in-one solution. You should still proofread and correct your captions because more often than not they're wildly incorrect, repetitive, or way too long. I've mentioned Notepad++ in past videos. It's very handy. It can be used to find and replace or delete incorrect tags in multiple captions, or if you've organized your images beforehand, it can be used to append tags to subsets of your image data. For example, put all the Captain Kirk images in a directory and tag them with the WebUI. Load Notepad++ and open the search menu and select Find in Files. Select the regular expression button and put a caret character in the Find What box. This tells the search to match the beginning of any line. Put the extension of your caption files in the file extension box, and then select the directory for your files. In the replace box, put the phrase you want to append, followed by a comma and then a space to maintain the comma separation in the caption file. Once you're sure all your boxes are correct, hit Replace in Files. This is very annoying to correct in thousands of files if you happen to make a mistake. Dreambooth datasets need to be named and organized in a specific way. Make a dataset directory with any name, and then put each set of training images into its own folder. Name the folders with the number of data repetitions, then an underscore, and then your tag name, and then the class name. Put the class images into folders named the number of repetitions, underscore, and then the class name. Fine-tuning datasets are a single directory with images and captions. This training startup script here is a command line example from the project's GitHub page, but altered for Linux. Descriptions of the flags are available on the project page, so I won't go over them in detail here. The script has various optimizations built in that are a trade-off between training speed and memory use. If you have a 12GB GPU, you may be able to run a batch size of 2, but decrease it to 1 if you have any out-of-memory errors. Specify the xformers tag to use the xformers memory optimization, and adjust the save every n epoch to whatever interval of epochs you want your checkpoint saved. There seems to be a bit of a logic error in the script, and currently the training stops and saves after one checkpoint regardless of your settings. The way to overcome this at the moment is to specify the max_train_steps flag with a number greater than the number of steps in n total epochs. This will allow the training to continue after saving an epoch. So basically just put a very high maximum step count. Dataset repeats will virtually duplicate your data and grow the number of steps in an epoch. This may be useful if you have a very small dataset. Set the dataset directory and output directory for your use. Set the model name to correspond to a Hugging Face model or a locally downloaded diffusers model. The script is supposed to be able to use the Safe Tensors library to save models, however I haven't had any luck getting that to work yet. I used the conversion script from the Shivam Shiraro diffusers project to convert the diffusers weights to checkpoints for the WebUI. I've been fine-tuning a model using the same image data used in the last Dreambooth video, so I won't go over the dataset again here, but rather take a look at how the model is progressing between epochs and show some comparisons with the base model. So I've converted the diffusers weights to a checkpoint after one epoch and loaded it into the WebUI. The training images are tagged with each character's name, so hopefully a little of that carried through to training the text encoder. Let's try with an image of Tasha Yar from the next generation. Not bad, but it's a fairly well-known character, so this is probably mostly carried over from the original model. So I'll switch back to the Stable Diffusion 1.5 model and compare. The face is a little off, but the makeup, hair, and environment look good. And when I say good, I typically mean appropriate to the composition, not necessarily good as in the most optimal, high-resolution, high-quality, shiny, glossy image that can be generated. The base model does a decent job with the characters and composition, but the facial features are pretty weak here. Let me skip ahead a bit and I'll load up a checkpoint after 16 epochs for evaluation. Better or worse, I still think it's a little too early to tell here. The facial features have softened and the level of detail is still there, so it doesn't seem like the model is being burnt with a learning rate that's too high. Seems like things are progressing. The face shape looks better and the detail is improving, but it still has a ways to go. There were a lot of studio photographer promo shots in this dataset, so I think that's carried over to the model. But as you can see, things like the uniform are completely off. This is only a small subset of the potentially trained data though. So for another prompt, I'll try to conjure up something resembling Counselor Deanna Troi from Star Trek The Next Generation. That's an eerie resemblance, but again it seems to need more training. She had some pretty distinctive hair in some episodes and it's picked up on that, but again the face needs a little more training. It'll start to look younger as the model moves closer to the training data. I tagged some of the more distinctive looking female extras and secondary characters from the original Star Trek series with the generic Star Trek The Original Series tag, in addition to the Dan Boro tags. I'm hoping to see the hair, makeup, clothing, and lighting carry over, but I'll probably get a little bit of the film grain as well. I think it's on the right track here. It's got that 60s vibe going on. Let's load up the Stable Diffusion 1.5 model and generate a few images to compare. Well, the uniforms are alright, but the overall image isn't great. And this one is a mess. And here we're missing heads. So yeah, I think the fine-tuned model is an improvement over this. The male figures are coming along pretty good here as well, with this one vaguely resembling William Riker, and Jean-Luc Picard slowly being molded from information clay here. The base model doesn't do a good job at recreating him. My guess as to why is that the original training data contained photos of people cosplaying as Picard, fan art drawings of Picard, painted book covers featuring Picard, and other various not-from-TV depictions of Patrick Stewart playing Jean-Luc Picard. So it's dirty data, done dirt cheap. With 36 epochs, you can see that Troy's looking a little more youthful, but the face still isn't quite right. With high-res fix enabled, higher values will incorporate more of the second pass, and lower values more of the first pass. You may notice radically different face quality at either midpoint, so around 0.4 and 0.7-ish. Early on, you may find that you need to raise the CFG value to access the data you're attempting to train, or use brackets for emphasis around the sections of your prompt, or you can try both. Revisiting the Tasha Yar figure at 36 epochs, it looks quite a bit more lifelike. I was able to get higher quality images for later Trek series, so let's see how it performed trying to conjure up Michael Burnham from Star Trek Discovery. Things are a little off, but it looks like this trained up better than some of the other data due to the image quality, or maybe because the model has a lot of data on this already. One of the more difficult figures to get going is Geordi LaForge. So far the model has picked up on the unusual eyes, unusual eyewear, but doesn't know quite enough or what to do with any of the information yet. I'm going to try to take this model up to about 200 epochs and show how things progressed in a follow-up video. In the next part, I'm going to try to go over fine-tuning the Stable Diffusion 2 model, Dreambooth training with the Koya script, and training at higher resolutions as well. No promises though, I'm limited by computing resources and failing health. Let me know if there's a specific thing you'd like to see in the next one, and if it fits, I'll put a higher priority on incorporating it. I'm going to end things here to keep it under the 20-minute mark, and if I forgot to mention anything, leave a comment and I'll try to fill in the gaps. Thanks for watching, and thank you to all the subscribers. The channel's at almost 500 now, which I think is pretty great for my weird, niche nerd videos. I'm actively working on the next video, but if for some reason I don't post anything before the end of the month, happy Christmas and happy holidays everyone.